Thanks, guys. Who's using serverless on production? Pretty good. Yeah, I've got a lot of stuff to talk you through, guys, today, and hopefully we'll keep you awake before the coffee break. So there are two main parts of the talk today. One is I will take you through a bit of the journey that we went through recently, evolving our architecture, and at the same time, we're taking the opportunity to adopt serverless. The second half, I will dive into a couple of the challenges that we faced and some of the key takeaways I want to share with you. So I hope some of these could resonate with you and inspire you to start your serverless journey in your organization. So our journey. We at ABC have a whole ecosystem of digital product and APIs, but today I just want to focus on one platform. It's our content API. It powers some of the audience-facing digital products. And in a nutshell, what it does is aggregates and normalize our content from a number of different data sources. For example, the news article CMS. It needs to scale fast to handle spike traffics, like this one. The baseline traffic there is about 150 to 200 requests a second, and the spike is 2,500. So this was the architecture we had about a year ago. The API layer runs on a bunch of EC2 instances, very typical stuff you see. Audience traffic hit the API, or API will ingest content, will then aggregate and normalize and serve the traffic and pop into the cache. When the content got published in the CMS, notification will hit the API, which then fetching content and triggering API to update the cache. All good. Few problems. We have a centralized ingestion function that embedded it within the API layer. How to deal with a number of different data sources, like news articles, program schedules, music playout data. They're all very, very different data structures and different caching rules we have to deal with. It's also embedded within the API with orchestration workflows. And audience traffic and the internal notification hits both the API layer, which is not very good in terms of prioritizing audience traffic. So infrastructure-wise, all the typical stuff EC2 that you have to manage in provisioning, config management, patches, all the fun stuff you know. This is what we landed with. Separation of concerns, separate ingestion layer. The key difference is the internal notification doesn't go through API, will hit the ingestion layer, which focus on ingestion, and API focusing on orchestrating them. The ingestion layer consists of a number of different functions now that each is made unique for each content source. Because we have this layer of abstractions now, we can actually collapse the traffic through to the upstream content source, which dramatically reduce their load and cost. So we now run the ECS Fargate on the API and also Lambda function for the ingesters. You might want to ask why when we go with Lambda all the way through. We did consider a lot of different reasons to make the decisions, but in summary, this is a bit of a checklist I recommend you to consider if you would like to make such similar decisions. So when you do your forecast of the usage or the cost, you wanted to make sure you future-proof your decisions. So not only not only do it based on your current traffic, but make sure you consider a few other options like double, triple, or even 10 times the traffic, just having that growth mindset. Obviously, Fargate and ECS and Lambda, they scale much faster than EC2s. Whereas Lambda scales almost in real time. In terms of level of controls and limitations, they are often subject to personal preference. So it's a key to figure out whether or not your team is going to be comfortable of navigating them. Often it means there will be some learning curves, some change in terms of code structures or deployment processes or development patterns. So make sure your team is comfortable with all the changes and think they are opportunity to learn and expand instead of obstacles. In terms of effort estimating, so beyond just making sure that think beyond just the basic things of making things work, consider all the bells and the whistles you have to productionize at the end of the day. And also, there's a lot of stuff that's going to be involved beyond just re-architect your application. You will have to probably change your monitoring systems, do a whole bunch of testings. So all of this, I recommend you to consider early and start as early as possible. So also, you don't want to try replacing the whole entire monolith with a new serverless architecture in a big bang. So do plan in phases. We did containerization, the API layer itself. Then we separate out the ingestors functions. So during the second phase that I mentioned, we actually soak tested the new architecture. What that means, we replay the entire production traffic on the new testing stack for extended period of time. This really helped a ton in terms of functional tests, regression tests, and performance testing. We learned a ton on the system behaviors, such as Lambda cold starts, or figuring out what metrics we need to monitor, or how can we monitor them. So speaking of the cold starts and also monitoring, or segue to challenges, it's not a serverless talk if we don't talk about Lambda cold starts. So cold start is actually only a problem if your function doesn't get invoked once every 10 minutes, and you care about the latency a lot. So otherwise, it's not a problem, happy days. In our case, a bit of extra latency on notification process is fine, and during our soak testing, we benchmarked the amount of traffic coming from API to the ingestors. We know that we will have consistent traffic throughput to keep them warm. But when we deploy the new version of Lambda functions, it's always going to be cold. So we can't just give our audience a spike of latency every time we deploy something. What we did was, we learned that we could change the invokers to call the alias instead of the function directly. That actually decoupled the release from the deployment, which is usually a good thing to do in any architecture. And we also created a warm-up function that it invokes the new version with a special warm-up payload, and more importantly, with a concurrency that is similar to the live traffic. So the hint is that to have at least 100 milliseconds sleep in your Lambda function that handles the warm-up payload to get the concurrency taking effect. So once the new version is warm, the last step is release your Lambda by simply pointing the alias to the new functions. So next up, monitoring and observabilities. Monitoring is failure-centric. In the event of failure, monitoring should provide visibility of the impact of the failure. And when you deploy the fix, monitoring should really provide you the feedback on the effectiveness of your fix. So monitoring provides an overview of system health, but monitoring doesn't prevent failure entirely. So you can have a very, very effective monitoring system, but it doesn't guarantee that failure can be completely avoided. Observability, on the other hand, is all about granular level of insights and rich context. So monitoring is failure-centric, but observability doesn't necessarily have to be. Twitter engineering defined these 4 pillars of observability engineering. Interestingly, that it's a superset of monitoring plus alerting, distributed tracing, and log analytics. But what matters at the end of the day in the context of serverless? So if there's no server, you don't need to monitor the instance staying up or the health check stay green. So figuring out the failure mode of the system is the key to monitoring. Your monitoring needs to tie up with your metrics, your infrastructure, of course, but more importantly, your application metrics. Logs also include events, traces, exceptions, as they're all kind of variant of logs. In fact, the most effective approach of Lambda monitoring is done via logs. I will touch on that soon in a second. So beyond the monitoring for failure, our goal should be, one, to really better understand the performance and behavior of our system in their normal operation. Two, to understand the shortcoming of our system and the evolving need of them. Three, then to validate your assumptions about your system design and the decisions you made. I will take the example, you would have to design your Lambda function to have a certain CPU memory size, similarly your containers, or you have assumptions on your application transaction time or the impact to your upstream and downstream systems. All of these assumptions, if you have an effective monitoring system, you could measure all of this up and adjust your decisions accordingly. So I want to quickly mention X-ray in the context of Lambda. One good thing about Amazon X-ray is that you can annotate the hell out of your Lambda functions, but it doesn't make any impact to the or overhead to the execution time, because they're all done and collected in the background just like Lambda logs. So in the console of X-ray, you can group or filter by them, by your annotations, and have an overview of average execution time and their proportions. Similar to errors, you can group and aggregate unique error messages. But the single trace detail page on the screen now, personally, I don't think is very useful, because what you really want to see is a time series of aggregation of all traces during a given time window. Well, however, there's an X-ray API that you could use to query all traces, not examples, that you can do all kind of in-depth analysis or aggregation yourself. Logging in Lambda, as I mentioned previously, doesn't add overhead to your execution times. Logs are sent to CloudWatch log asynchronously in the background. So taking advantage of that, any of your custom metrics or your code instrumentations you want to do them in logs. Then you can have a dispatcher Lambda function that subscribing to the CloudWatch logs, then sending the actual log to your logging service, and sending the metrics to your monitoring service. So one of the bigger advantages I want to touch on using monitoring service like New Relic is having that time series-based aggregated data that I mentioned, so I can have an overview of how my Lambda functions are performing, as well as give me the insights of the observability, such as error rates or cold starts over time. So we're going to continue our journey on evolving our platform and APIs. I simplified the API management piece out of the diagram that I showed you previously. There is actually a cluster of auto-scaling group of EC2s as a front gate of the API. Does the API management piece. We are thinking about replacing that with a hybrid solution of using both Akamai and Amazon AWS API gateway. Another one to tackle is perhaps maybe the cache cluster. It's currently multi-AZ, it's replicated, but still, we have to deal with security patches, maintenance windows, or that potentially means downtime or degraded services. Who want to deal with all of those kind of stuff? No one. So perhaps we could serverless that one as well. So yeah, that brings to the end of my talk. I hope some of these are useful for you, and thank you very much for listening, and go start your serverless journey today and have fun.